Welcome to AI driven perception, learning and mapping for drones. This particular course is going to be covered by myself. I am Professor Suresh Sundaram, Chairman of Department of Cyber Physical System, also Professor at the Department of Aerospace Engineering and IISc, and with my colleague Dr. Anirudh Sikdar. He is a postdoctoral researcher at Department of Aerospace Engineering and IISc. What is this course is all about? Let's look at the objective of this course. This will introduce students the fundamental principles of neural networks and its supervised learning algorithm. When I say neural networks, it will include both shallow and deep neural network. When we talk about drone perception, learning and planning, when the drone flies, it sees the external environment. It has to understand the context of the environment to identify whether there is an obstacle, there is no obstacle, or what is in the scene. Is there any targets of interest? What action it has to perform? For that it requires learning. Right? For some time we may also operate the drones in cluttered environment where signals may not be there. We may have to estimate the signals. In such cases we may need a shallow neural network, recurrent networks to predict the signals. In such cases we need to understand the both shallow as well as deep neural network for autonomy aspects of the drone. And students will get familiarized into core components of CNN. Basically we are handling image and video, right? We need to understand how image can be processed for a specific task like segmentation, detection and tracking, right? Whenever we talk about context in which the drone is flying, it has to segment the area into different groups, right? Whether it's a tree, whether it's a road, whether it's a farm, whether it's a pillar, like it has to differentiate that. Or it has to look for objects. Let's say if you are using for surveillance purposes, you want to track a bus which is on the road. Then you need to detect the bus continuously from every frame, and motion of the bus has to be estimated and given as a feedback so the drone can continue to follow, right? So you need to know how the visual sensor, which is talking about extrinsics of the drone, identifying objects either by detection or by segmentation. For that we need understanding of CNN, so that will also be covered. Once the key concepts are covered, we will be looking into generative modeling. When I say generative modeling, you may not get data all the time, right? How will you handle for unknown objects or unknown domain? You may get an object in a bus, auto rickshaw, car going in a city traffic, but you want to know how it is going to look like in highway traffic. And you also want to understand how the data going to be in the rainy time, sunny time or snow or smoke. You may have to use generative data. Once you use the generative data, there will be always a domain gap between the generated processing and the actual processing. One need to understand how we can generate a data which will augment the network to learn better, and you can use it for those domain too. That concepts will also be covered during the course. We will also introduce into mapping and distributed AI for decision control. Moment I say drone, swarm of drones can fly in an environment. When the swarm of drones flies in an environment, it requires much complex decision making capability, right? When I see a target, other drone will also see a target. How the drones will take decisions, right? Who will go and handle that particular target, right? That requires distributed decision control mechanisms. Now other aspect comes into picture. Even a solo autonomy of a drone, single drone, when it performs the aerial mapping, right? You can reconstruct the area and you can generate digital surface map, or you can even generate digital representation of the 3D environment, which could be later used for estimating the pose of the drone when it is flying in that environment too, right? So how do we do mapping and distributed control will also be covered in the part of the course. Once we complete this, we looked into broad applications of these techniques. First is you need to understand foundations of learning, and then CNN, and then generative models, and how decision control and mapping. Then we look at applications domain, right? When we talk about aerial perception aspect of it, planning aspect of it, and mapping, right? We also bring in practical skills in developing learning methods, like when the data is generated by yourself, how do you annotate the data such that these methods can learn? How do you label it? How to generate the label in a way that it can be fed on to the network? And both data annotation and label generation will be carried out in MATLAB environment as well as PyTorch environment, so that you will get exposed to. We will also introduce, once you develop these models in MATLAB, how you can download them directly into a specific hardware, right? At the end of this course, student will be able to understand modern neural network architecture and apply the concepts for perception, planning and control tasks, and ability to analyze the model, develop perception system for aerial imagery. See, when I talk about aerial imagery, the challenge comes if the camera looking vertically downwards is more like a satellite. If the camera is in front of the drone, it's more like an autonomous car. If the camera position can change, what we call as a slant angle view. It can go from 0 degree all the way to 90 degree. When this view changes, the scale of the object will also change. How the object represent in the camera plane will also change. So you may have to develop a robust architecture. Again we talk about aerial perception, right? So we may not be just using RGB camera, right? Sometimes we may use infrared, sometimes we may use SAR sensors or multispectral sensor. Let's take an example of agriculture space. In agriculture space, the purpose is to bring precision agriculture. When you say precision agriculture, you wanted to know what is the green content on the plant, right? If the chlorophyll content decreases, you know there is some infection in the plant, that's why the leaves are not green. You can go and apply precision spraying in those locations. If you look at the soil surfaces, subsoil, you can look at soil moisture, NPK contents of the soil, which will help the farmer to understand where they need to apply necessary minerals and moisture for the plant to grow. Right? There you will be handling either multispectral or hyperspectral camera. So you need to understand mapping of this. For example, if you look at EO and IR, electro-optical, which is nothing but your RGB, and infrared will capture something common in both the objects, and they will have something unique also. In RGB you can understand the context, whereas in IR you can understand the thermal characteristics of the materials present in the object. That is not seen in RGB, right? This is like some complementary information and there is some common information. You may not have a sufficient data in that particular sensor domain. How do we do the transfer learning when we talk about these aerial images? These are some of these important elements we will touch base. It will help the student to think beyond this particular course. Okay. So what is this course about? Are we going to cover everything or what are we going to cover? Right. First module will talk about foundations of neural networks. So understanding the building block of feed-forward neural network, learning paradigm, and when we talk about learning there are issues, right? Training, testing, validation. Generalization is a very important characteristic. It's like any other course what we teach, right? It's called when the student gets trained on those topics. But when we test it, we don't give the same topic. You may have to apply the concept what you have learned on the newer problem domain that talks about how good you understood the subject. The same way we call this as a generalization, how well the network learn the relationship between the data and apply the relationship on unseen data. That's a generalization aspect. We will discuss that in detail. I am just trying to give you an essence of what we will be talking about, right? How we will be using these network for applications in aerospace, right? Not just on drones, you can also look at structural health monitoring of the whole drone itself. If there is a vibration, vibration shows certain characteristics of the drone, right? If suddenly you see one of the arm has a crack, the vibration will be different in that particular case. By looking at the different vibration signature, you can look at the health of the drone also. Right? We will look at some of these applications, how we can use it in shallow neural network. Now, second module talks more about foundations of convolution neural network. Here we talk about understanding of the image data structure, convolution operations, different operations present here. We talk about activation functions, learning aspects of it, deployment of this CNN into smaller hardware edge levels so that you can use for specific purposes. What specific purpose here we will address? Aerial surveillance. Okay. Now module 3 is all about feedback neural network and transformers. You remember I mentioned in the beginning, when the drone flies in a cluttered environment, we may not get the GPS signal. GPS denied is one of the biggest problem in drone operations, right? If you are flying the drone indoor, getting the position of the drone is the biggest challenge. The only way we can do is we can use the intrinsic sensors. The intrinsic sensors are nothing but your IMU, right? For height measurement you can use LiDAR or radar, right? That will give the height of the drone. But you need to estimate the state of the drone. What are the state? You may have to estimate what is the velocity in all three directions, position in XYZ directions, that what we call translational parameter. Then we have rotational parameters, phi, theta, psi, what we call attitude of the drone, how the attitude changes with respect to time, rate, right? PQR, pitch rate, roll rate, yaw rate of the drone. It is very important if you are performing a specific operations of using the drone in such a cluttered environment. If you do not have the sensor to measure directly the rate, how will you control it? The only way you can do it, estimate these states from the measurement. The measurement is IMU, what I mentioned, inertial measurement unit, which has accelerometer and gyro. The accelerometer and gyro has to be used to estimate UVW, XYZ, phi theta psi and PQR. These are internal state. That is why we call this as intrinsic sensors, right. You can use extrinsic sensor also to measure states of the system. For example, I can use a camera to vertically point downwards, and using that I can identify UVW, what we call optical flow based estimation. Another thing is, in a common navigation purpose, well known locations, we know the location and those locations are recorded in our mind. If we can identify that using an extrinsic camera, I can identify the location of myself with respect to known objects, right. So extrinsic sensors also sometimes used to measure. If there is a GPS, then I do not have to worry about it. I can get my global positions. With that I can navigate myself. So we need a recurrent neural network to estimate my position using this intrinsic sensors. So you need to understand how the feedback neural network works. Why feedback neural networks? What is why it is needed? How it is different from other neural network? We will discuss in this particular module. But sometimes you want to understand what is happening on the context for decision making. Then you need to look at temporal information of the camera, right. Different frames, how the object is moving, to understand the intent of the object. If you really wanted to do, then you need to bring in this recurrent structure in image processing. So that becomes transformer architecture. We will talk about it in the module 3. Module 4 is more about generative AI part of it. We will discuss more on variational autoencoder, generative adversarial neural network and diffusion models. As I said earlier, data may not be available in all scenes or all domains of interest. How do we generate data in those domains where the drone is going to fly? If you want to generate such kind of data, you need to know generative AI aspect of it. We will be covering that in module 4. Module 5 is an application module, right? Once you have the basic foundation built, we will be now focusing on aerial visual perception and understanding, basically segmentation, detection, and we talk about continual learning aspect of it, a zero-shot continual learning aspect of it. Continual learning is nothing but the number of objects in the scenes are not going to be fixed. It's going to keep growing, right? You have to keep training the network when new data comes in. That's not going to help. Can I learn whatever the objects coming incrementally without forgetting what I have learned earlier? Or I may not have the data. I may have the verbal description about the data. With the verbal description, can I learn its visual features? That's zero-shot continual learning. These are very, very important when we talk about aerial visual perception and understanding of it. Not just only in the camera plane, you also have to look at the IR imaging, right? RGB to IR. How do we do the knowledge transfer from one domain to another domain? All this will be discussed in module 5. Your module 6 is more about reconstruction and localization. Here again we will talk about neural radiance field, Gaussian plotting, which will help you to understand how you can reconstruct the scene which is being observed by the camera, how to use this 3D reconstructed scene to estimate the pose of the drone or pose of the camera with respect to that scene. If I know the pose of the camera, I know the pose of the drone. If I know the pose of the drone, I know where I am pointing out in the operational zone, which will help me to localize myself, estimate my states and navigate more efficiently in a denied environment, right? Finally, we touch base on distributed AI and decision control. Here, moment we bring in swarm, the missions are going to be different for different scenario. For example, if you look at a forest fire, you may have a large fire, you may have a small fire. Now the question is, how many drones are going to work together to quench the larger fire? How many you need for smaller fire? Will I attack the larger fire first? Will I attack the smaller fire first? How they work together, right? If we talk about perimeter defense, I just talk about an airport which need to be defended from smaller drones so that the aircraft can fly. Who will go and defend? Because a larger area, right? You talk about at least a 10 cross 10 square kilometer or 20 square kilometer region, I have to defend it. Confinement escape, right? Somebody is intruder, I want to catch the intruder before he escape from the zone. So every problem has a different objective. How these drones can take decisions such that the swarm's benefit or the mission is accomplished, right? So we will take one or two use cases and explain how distributed AI comes into picture for decision control mechanism. The module 6 and 7 is an advanced module which will help students to pursue research. The module 5 is more an application module. Again, it will help someone to do projects in those domains. Okay? But module 1, 2, 3, 4 are foundational concept which helps student to learn and apply not only in aerial perception, it can also be used for robotic perceptions and even autonomous vehicle, ground vehicle aspects of it. Okay. What are the books we are going to follow? For module 1 and 3, shallow neural networks, when I talk about it, I'll be following this neural networks and learning machines by Simon Aikens, right? When I talk about CNN, I will be using multi-view geometry of computer vision. This is another reference book which you can use, or you can look into deep learning. This is also a very good book if you really wanted to learn beyond what is being covered in this particular module. For a distributed control aspects of it, that's a last advanced module, you can look at reinforcement learning. This is a very interesting book which will help you to understand on how reinforcement learning is, or how they can be applied to autonomy aspects of the drone, or what we call end-to-end navigation aspects of the drone, or even a swarm of drones to perform a specific missions and all that. Foundational knowledge you want to build, you have to read through this particular book. So these are some reference books that one need to follow.